This video covers putting it all together. The structure of this video is as follows. Data, initial visualization decisions, SVG viewport and margins. Scale data, set the domain. Scale data, set the range. Define and call the axes. Data representation, binding data to SVG elements. Adding attributes to SVG elements. Adding text labels. JavaScript console example, and the summary. Alright, let's get started. Data. We define a dataset that contains text and numbers. This dataset is based on the top 50 largest cities in the world and their population as measured in millions according to Wikipedia. For now, we design a super basic data visualization. We will create circles where the radius is based on the population in millions. Then we will add the name of the city next to the circle. We position the circles on the graph based on their index number. Initial visualization decision. Given the dataset, we have three possible variables: population, rank, and name of the city. Given that population and rank are both numbers, it is easiest to start there. Which variable is dependent and which variable is independent? The rank variable is dependent on the population variable. The bigger the population, the higher the rank. So rank should be the y-axis and population should be the x-axis. For now, we will stay in the SVG coordinate space. So if rank should be the y-axis and population should be the x-axis, then what kind of line should we get? When we are done building the data visualization, this is what it will look like. Shanghai will be at the top right, while New Taipei will be at the bottom left. Let's go over the steps before we do it in the JavaScript console. SVG viewport and margins. To make the data visualization fit into the screen so that we can show the Chrome Developer Tools, we choose the SVG viewport dimensions as 300 by 300. Then we choose the margins of 50 on each side to give plenty of room to the chart and the axis we will draw. The SVG viewport and margins will then help define the inner drawing space. Having decided on the SVG viewport dimensions and margins, JavaScript variables and selections are defined so that we have the viewport, the margins object, and the inner space. Scale data, set the domain. We have to define what the scales of the data set will be. Rank as the y-axis starts near enough to 0 that we can say 0 to make the graph look clean because it starts at the origin. With the rank increasing to 50, we can make it 50 for a nice round number. Population as the x-axis starts near enough to 0 that we can say 0 to make the graph look clean because it starts at the origin. With the population increasing to almost 18, we can make it 20 for a nice round number. Note, we could use the D3 extent formulas here to get the max and min. We do not use them to keep things simple. Knowing the min and max of the x and y coordinates, we can set the domain of the scale. Scale data, set the range. Now that we have the domain of the scale, we have to set the range of the scale. Given the SVG viewport, margins, and inner drawing space, we can set the range of the scale easily. The inner drawing space width is 300 units minus the left margin, which is 50, minus the right margin, which is 50. So the inner drawing space width is 200 units. So the range of the x-axis scale should be 0 to 200. The inner drawing space height is 300 units. Minus the top margin, which is 50 units, minus the bottom margin, which is 50 units. So the inner drawing space height is 200 units. So the range of the y-axis scale should be 0 to 200. Knowing what the range should be, let's redefine the x-axis scale and y-axis scale. Now we have the full scaling function necessary for the data visualization. Define and call the axes. We define the x-axis and the y-axis functions, scale them, and give them an orientation. The x-axis will be horizontal, the y-axis will be vertical. Note that we have to use different scale functions for the different axes because they cover different domains. Then we have to call the D3.svg.axis functions for the x-axis group and the y-axis groups. This will create the axis components in the inner space. Data representation. Next, we have to decide how each of these data points is going to be represented. To remove clutter and to make it easy to see, let's treat this visualization like a scatter plot. Each data point will be a small circle. Each circle will have the same radius as the others. Each circle will be black. These are both things we know how to add and represent given data, so that is what we'll do. We'll bind data to the elements and create SVG circle elements. Binding data to SVG elements. First, we append an SVG group element because we want to group all of the circle elements together. Here we use the D3 pattern. We select the SVG space we are going to use. We select all the element we want to add. We bind the data to it. We select the enter selection as there were no circles in this particular selection before. Then we merge the placeholder JavaScript objects with the SVG circle elements. This binds the data, but does not create the circles as we have not provided attributes to the circles yet. Next, let's provide attributes to the circles to make sure they appear. Adding attributes to SVG elements. Next, we add attributes to the circles to make sure they appear correctly. We also do it in a way that produces scaled data points from the real data. We use the scale function for this. Note, we have a different scaling function for each x and y axis, so we need to make sure we use the right one. This is important to pay attention to. When you have different scales for the x and y axis, you need to make sure you use the right one when defining attributes and setting their values. For circles, the cx values will use the x-axis scale function. The cy values will use the y-axis scale function. And if available, the radius could also use a scaling function. The example we are building does not vary the radius, so it is constant for all the circles. The x-axis scale is used to scale the bound data for the cx point. In this case, the population is the x variable, so we use the dot notation to get that population value out of the JSON object. The y-axis scale is used to scale the bound data for the cy point. In this case, the rank is the y-axis variable, so we use the dot notation to get the rank value out of the JSON object. At this point, you would be able to see each circle on the chart and how it corresponds to the x-axis and y-axis. What's missing now are some text labels to tell us what city name belongs to which dot. Adding text labels. First, we append an SVG group element because we want to group all of the text elements together. Like the circle example, we use the inner drawing space to select all SVG text elements, bind the data set to them, choose the enter selection, and then append SVG text elements which merge with the JavaScript object placeholder element. Then we have to set the attributes. Just like the circle attributes, we have to define the x and y coordinates of where the text will live. Also, we have to define the text that goes into the text element. The x and y coordinates will be pulled out of the JSON object that was bound to the text element. The text attributes will be the x and y coordinates and the text. The x coordinate is the scaled population. The y coordinate is the scaled rank. The actual text of the SVG text element is the name of the city. We add a red color to the text so that it will be different from the black dots. And with that, we have all the information necessary to create the data visualization. JavaScript console example. First, we define the data we will be using. You can see that it returns an array of 6 objects. We will later bind each of these objects to an SVG circle element. Next, we define the SVG viewport. The width and height are defined in such a way as to make sure it fits into the window so that the Chrome developer tools are visible. Here you can see the dimensions of the SVG viewport container on the screen. Next, we define the margins per D3 margin convention, noting that the width and height are going to be used as definitions of the width and height of the inner drawing space. Next, we define the inner drawing space. First, we attach an SVG group element to the SVG viewport. Then we translate this group element by the margin left and the margin top. This moves the inner drawing space 50 units to the right and 50 units down. You can think of this as being where the new coordinate space is defined that will house the data visualization. Next, we define the x-axis scale and y-axis scale. The x-axis scale is based on the x-axis value, which represents the population size of the city. The range for both scales is 200 because that is the height and width of the SVG inner drawing space. Next, we define the circles that will be created in the inner drawing space. We attach an SVG group element to the inner drawing space in order to hold all of the circle elements. Then we bind the data, select the enter selection, and merge the placeholder elements with the SVG circle elements. As you can see, there are now 6 circle elements in their own group element inside of the inner drawing space group element. Next, we give each circle CX, CY, and radius attributes to make them appear on the screen. We use anonymous functions as well as the scaling functions to take in the data that was bound to each circle to add values to the attributes. You can now see the 6 circle elements. You can also see that the CX variable has been scaled up so that the first circle's CX attribute is 180. The X data point for the first circle was 18, so you can see that the X scaling function is multiplying the domain numbers by 10 to get the range numbers. Now that we have the circles, let's define the axis elements so that we can build the axes. Next, let's call the axis elements so that they create all of the necessary axis elements for us. You can see that D3 has created the horizontal x-axis for us as well as the vertical y-axis for us. If we close the SVG group element that contained the circles, you can see that there are 3 SVG group elements within the inner drawing space group element. As we hover over each one of the group elements, you can see that the first group element encapsulates all of the circles, the second group element encapsulates all of the horizontal x-axis elements, and the third group element encapsulates all of the vertical y-axis elements. This is useful in case we want to move or translate the axis elements or to apply certain attributes to all of the elements of one of the SVG group elements. Lastly, let's add the text to the data visualization. We attach an SVG group element to the inner drawing space in order to hold all of the text elements for the circle labeling. Then we bind the data, select the enter selection, and merge the placeholder elements with the SVG text elements. As you can see, there are now 6 text elements in their own group element inside of the inner drawing space group element. Also, notice that we added another group element which holds all of the text elements. This was appended as the last child element in the inner drawing space, as this is how the append command works. Finally, let's add the text attribute so that the text actually appears. We use anonymous functions as well as the scaling functions to take in the data that was bound to each text element in order to add the values to the attributes. You can now see the 6 text elements. And there you go. You can see the full data visualization based on the original data. We were able to use D3 to add the horizontal x-axis, the vertical y-axis, the circles, and have them correctly scaled for the graph as well as the text labels. The summary. This video covered data, initial visualization decision, SVG viewport and margins, scale data, set the domain, scale data, set the range, define and call the axes, data representation, binding data to SVG elements, adding attributes to SVG elements, adding text labels, JavaScript console example, and the summary.